we are going to be looking at the physics practical for this NECO exam. This is my prediction, the possible thing you are going to see in that exam on that very day. So this is the spiral spring, the mass hanger, the restore stand, and then the stopwatch is here. That's the stopwatch here, you know. So now from let's look at the question so that we'll appreciate what it's all about. So the question I have here is using the diagram above as a guide, carry out the following instructions. Suspend the spiral spring vertically as shown, just like what we have here. We have it here already. Then said suspend a mass hanger on the free ends of the spiral spring and then 40-gram mass on the hanger. Pull the hanger gently downward and release to set it into vertical oscillation. And when you draw it, then the oscillation will start. So determine the T for 20 oscillations. Another one, evaluate the period T for 20 oscillation. Also evaluate T squared, that is period squared. Then repeat the procedure for four other values of M: 60, 80, 100, and 120. In each case, you repeat all these things, you get the period square, and then the time for 20 oscillation. So I'm going to show you how this thing is going to look like. Although I've already done this practical, that so that we might not be spending so much time. What I have tonight to, by the time I show you what it's all about, I'll show you the graph, how the graph is going to look like, as in when you are going to, what you are going to face in that exam. So here said evaluate is this evaluate K, which is 4 pi square over slope. And again, it said determine the slope and intercept I on the horizontal axis. So let's quickly go into this. So the first mass we have there already existing here is 40 grams. So we need to make it up to 60 gram mass, because this thing is far away from it. We're going to make it up to 60 gram mass. So we add another way to make it 60. From here it says 60. So now we're going to set it into vertical oscillation. It's also important not to make the amplitude to be very, very wide, because when it's wide like that, you will lose it will not be in harmony anymore. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, excuse me, this thing is not working. All right, let me repeat. Doesn't on that time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I stop here. What I have here is 6.59 seconds. So the next one, we're going to do it twice so that we can take the average. So we're going to reset. So the next one we do again. Why? Listen, what is wrong with this? What is wrong? Don't do this the next time. One, listen. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have another one, 6.2, 6.28. All right. So what happened is that I will show you what I have done so far, because I don't want us to spend so much time trying to do this thing, because of that I don't want this video to be too long. So this is just what you will be doing in each of these as you increase the masses. So at the end of the day, you'll be able to get all your values. So what I'm showing you, what the next thing I'm going to do now is for us to I will show you the graph I have already plotted for it, so that you know how it looks like, the nature of the graph. So this is my table, the table of values, what I did. And another thing you should note here is that all the units are carefully represented. Grams, you see the grams, you see the seconds, and second squared. It's very important when you're doing this thing, so that you will not be losing unnecessary mark. You will not be losing unnecessary mark when you're from small things like this. So I'm going to be showing you, the next I'll be showing you is the graph, how it look like, so that the question here said, in the question it said that determine the slope of the graph. The graph you're plotting, plot a graph of t square on the vertical axis and against mass on the horizontal axis. One of the things said, after it said determine the slope of the graph, which is s of the slope of the graph, x of the graph, and then determine the intercept I on the horizontal axis. Now when you look at this, you find out that the intercept. So this is the graph. This is the graph, how it look like. And then on the mass axis, I'm using 2 cm for 20 grams. For 20 grams, and then on the t square, or the period squared, you can see that I'm using, this is from this graph, the nature of this graph, this big sides gives us the this end from here to this place is 2 cm. Then you have another one, this is 4 cm. This is what 2 again, you have 6, and then we have 8 cm. 8 cm in a hole, that is for what, 0.1 units, or 0.1 unit of the period squared. So this is the how it look like. I have only one deviation there, every other thing entered very well. So this is where I'm going to be calling it the end of the class today. This is just to make you to prepare your mind for the exam, and then if you have any question, you can leave it in the comment section. I'll always attend to you, and then I hope to see you in our next practical question. Thank you. If you are joining us for the first time, you have not subscribed, make every effort to subscribe, and then remember to like and share. I wish you the best in your exams. Hope to see you again.